We work with, in my opinion, one of the most substantial problems in human existence today, which is the interface between man and machine.
People are used to having to learn how to operate machines. So we're effectively spending a lot of time learning how to use the tools rather than performing the actual task at hand.
The core operations of Ntention is to solve user intent interpretation in human-computer interfaces like virtual reality systems or augmented reality systems and robotic asset manipulation.
It's a real complex thing. We're trying to make a completely new interaction system that doesn't depend on what's existing before.
A system that's bigger than just a screen, it's bigger than just a touch and a click. It's actually about taking a lot of input methods and understanding what you want to do in a bigger level.
We need to understand how humans work, how they think, so we can make the optimal interaction system for them that is efficient and pleasurable to use.
Not just what the user does, but the context of which the user acts in. We're looking at both the environment around, the data points of what is happening in this exact split second, but we're also thinking about what has happened and predictions of what will happen.
So you know that the table is hard, the chair is soft, you have all these references. So what we try to do actually is kind of make a second brain. Not connect to the brain we have, but make a second brain that kind of looks at you and tracks your body, basically.
So we want to leverage that kind of idea, use the existing mental models that people have prediction patterns in the brain and use them in other cases for other interactions.
We don't do it as complex as the brain itself, but still complex enough that understands your intentions. And that could be understanding how your body movement is, how your eyes look, finger movements, maybe even your pulse or kind of your body temperature. Like anything can be tracked if it's seen that that has something to do and can show your intention.
We have the roadmap of building it, and we also have the people that can build it.
We believe that we can, with our new methodology, work with projects, current day project that has a current need for new interaction systems.
And then we move further, iterate upon it, getting more and more intuitive, getting to the core of what is inherently intuitive to human cognition, and kind of gradually implementing this paradigm shift in how we interact with machines.
Take an example of a robotic arm, which is a very technical task, but if you kind of decompose it in a challenge, it's basically to move something in a 3D space around and have complete control of it. So the idea is to kind of take a really complex task like that, extrapolate it and decomposing it in saying, okay, we want to solve moving 3D object in a 3D space. That's it. So our idea is if you do like this, use this methodology in several different projects, we can gain knowledge that is kind of like a toolbox that can be used in basically any type of interaction. We envision the Ntention framework in a future where you have completely different play rules, and very possible future where everything is kind of augmented. You have VR and AR everywhere.
The XR market, a combination of AR and VR, it's been growing rapidly the past couple of years. There are loads of opportunities in VR, there are room for more players, and there is definitely need for an interaction framework once the hardware gets there. We still need the software to catch up, and that's where we come in.
When we come to a future where AR, for example, is integrated in our lenses, there will be a need for intuitive interactions. And we can say, well, we have solved how to move 3D object in space. Why don't we use that on the operating systems?